Hello everybody, I hope all of you are feeling good. My name is Ali. Today I'm going to talk about transistor. What's the transistor? The transistor is a semiconductor device. The semiconductor device has two main functions. The first function is amplify signal, and the second function is work as a switching, either open switch or closed switch. We will see in the example. Semiconductor. Let's begin with the semiconductor. Semiconductor, like our processor in mobile phones or PC. So what's the first enemy to the semiconductor? Semiconductor is the first enemy for it is the heat. And how can it affect on the semiconductor? How can heat affect on the semiconductor? It affects in two ways. First way, it may destroy the semiconductor, or it reduce the performance. So what manufacturer companies do to solve this problem? Either to use a cooling system, either with water or with fans. Okay, in this presentation I will talk about classification of transistor, how many types, and so on, working, application, and examples. So let's begin. Classification of transistor. BJT transistor types. BJT refers to mean bipolar junction transistor. NPN and PNP. What's the difference between them? Actually, the difference, we'll wrote here. Let's make it bigger. The NPN, current flow from base to emitter. Whereas in the BNB is the opposite, from emitter to base. We will see what's the emitter and the base in the next slide. Okay, there is the other difference between them. Okay, let's assume this NBN transistor, NBN, and this is BNB. Here is collector. C refers to collector, and here B refers to base, and here it refers to emitter. E refers to emitter, the first letter. Okay. What's the difference? Here they are the same, NPN and PN, and the emitter. Both of them heavily doped. Whereas here there are both of them lightly doped. But here is the difference. The only difference is here in the collector. Here in the NPN, medium. Whereas here in the BNB, it's lightly doped. So this is the difference. Let's go to another slide. What's this? Yes, this is like what I said in the previous slide. In the NPN, current flow from base to emitter, whereas in the PNP, it's flow the opposite, from emitter to base. So let's go to another slide. Okay, working of transistor. I've just talked about classification of transistor, so let's go the working of transistor. Okay, What's actually the NPN and PNP? It's almost two diode. It's almost two diode. Here either BNP or NPN. Why? Like in the diode, we see BNP, one PN junction, but here two PN junction, and in the diode we have two layer, whereas in the PNP three layer. So 1, 2, 3. Okay. It's nothing but not just when I said some other slide. See here, as I said, emitter, both of them, NPN and PNP, heavily dope. Whereas like here, base, very lightly dope, both of them. The only difference, as I said here, intermediate for NPN and lightly dope for PNP. Okay. Let's explain the transistor. Okay, the transistor diagram consists of three layers, so three regions. Sorry, the first region it's like a maximum value of the current. It's called saturation region. Okay, the medium value of the current here called active region, and the last region is cutoff. Okay, cutoff region, or some will call it pinch off region. Pinch off. Okay. Okay. Saturation region. The transistor and the saturation region act like a closed switch. Closed switch. Whereas in the cutoff region, it works like an open switch. Open switch. Okay. That's what's said application of transistor. One of them switching. Okay. Yes, that's as I said. Video on, video off. Cutoff region, saturation region. Okay. Let's go to another slide. Examples. Example for analysis circuit of transistor. What's the question said? Transistor has beta DC 300. Calculate IB, IC, and VCE. First of all, let's talk about what's the difference between these two circuits. First one, ideal, and here second. What's this ideal and second? The ideal, to call it also first approximation, and here second approximation. What does the approximation mean? The benefit of approximation, when we go to from ideal to second, we will be more accurate, and when we go to from the second to the third approximation, we will be more accurate also. But when we go more and more, we can't solve it by a human's brain, so we need a strong computer to solve it. Okay, here also there is another difference in the VBE. Here base and here emitter. Okay, we call it VBE. VBE. Okay, here VBE, because it's the first approximation, 0. No, sorry, it is 0 because it is in the ideal approximation. Whereas here in the second approximation, we assume VB as 0.7. So let's begin to analyze the circuit here. First, it's this side for ideal approximation and this side for second approximation. Let's begin with the ideal approximation first. IB equal VBB in this loop, VBB minus VBE. What's VBE here? Ideal approximation, as I said, 0. And RB is 12 volt, 2 volt, kilo ohm. So volt today should be micro. What's the answer? Answer is 54.5 micro. Forget the unit, microampere. So IC, console for IC. IC is nothing but IB multiplied by beta. IB is found here, multiplied by beta. IB is 54.5. Sorry, but I'm writing with the mouse. Okay, multiplied by 300. It will be 5.45 milliampere. So what we notice here is very important note here in the base micro, but here the collector to be milli. So as I said before, one of the application of the transistor is that it works like an amplify signal, like very low current become bigger from micro to milli, very big difference. So how can a transistor amplify signal? By using variable resistor. So what else? What to begin? Yes, VCC. Okay, here VCC minus VC. Okay, which is which VCC is 12, and we find VC. Okay, VC equal IC multiplied by RC. IC, what's IC? Actually found it here, 5.45 milli multiplied by RC, 1 kilo ohm. So kilo will go with milli because 10 to the power minus 3 and 10 to the power 3 go together. Answer will be 5.45 volt. So we find here, what's this? We found it VC. VC equal VCC minus VC equal 5.45. So the answer will be how much? 6 point by calculator 55 volt. Let's go to the second approximation. What's the only difference here is that here in the second approximation VCB is 0.7. So IB equal VBB minus 0.7. Notice in the first approximation or title approximation minus 0. VB T RB 12.12 minus 0.7, 11.3. Okay, RB is 200 kilo. So answer will be 51.4 microampere. Okay, IC, same question. IC will be IB multiplied by beta, IB 51.4 microampere multiplied by RC multiplied by beta. Sorry, where's beta? 300. So it will be okay. I think there is a mistake in the problem. Yes, here beta. Sorry, beta is 100. It's not 300. So here, where is beta? Okay, multiplied by 300. Not 300 actually. Sorry for this mistake. 100. And here was 100. Okay, it will be 55.14 milliampere. So VCE same equation, VCC minus VC 12 minus you can't do it short actually. IC multiply VC, it will equal 5.14. okay, answer will be 6.84 voltage. This is VCE. Okay, what else? Yes, we arrived to the end of our presentation, so thank you for listening.